Recording? Okay, it's recording. Alright guys, this is going to be a real quick, less than 10-minute video, just to get you all not quite completing every single thing that you forgot over the break, because we're going to jump, straight back in as soon as we get back. No break. So first thing I wanted to do was make sure that you remember what we were talking about before, which was acceleration. So if you're talking about acceleration, we're talking about anything that's a change of a velocity. Remember that being a speed just with a direction. So that's going to include anything that's speeding up, anything that's slowing down, and also anything that's one more thing. Need to remember what that last one is. Okay, if you said changing direction, you would be correct. Because remember, I just said velocity is speed and direction. So changing direction is included in an acceleration. So speeding up, slowing down, changing direction, any of those three things counts as an acceleration. Okay. So here's something that you may not have known. So hopefully you intuitively kind of knew this. Normally things do not accelerate by themselves. And not even normally, just things do not accelerate on their own. It doesn't happen. In their natural state, any object is just going to continue doing whatever it's doing forever. If it's sitting still, it will sit still forever. If it's moving, then it will keep moving the exact same way that it was moving forever. If there was nothing that caused an acceleration. So, for example, you've all seen rocks. They don't do anything because they're rocks. Long as nothing does anything to them, they will just sit there forever. If you see one in one spot right now, you will continue to see it in that same spot for as long as nothing happens. Similarly, you may have heard that any satellites that we've shot off into space, they just keep right on going. Like the Voyager 1 probe or the Voyager 2 probe. Now that they've gone past Jupiter, Saturn, Neptune, whatever it was they were originally set out to look for, they just keep right on going, off into deep space. And as long as they don't run into anything, they will continue to just keep right on going, whatever speed they were going at, and never stop. So if this is the normal, then what is it that causes accelerations? Why do things change their movement ever? Clearly it happens, so there must be some cause if this is not the natural way of things. And that's true. And I think most of you already kind of, in the back of your head, know if something changes its movement, it's because something pushed it. And you would be right. That's a force. That's what forces are. They are anything that causes an acceleration. Simple definition that people like to use, like if you took integrated science, this is the one that I told you. A force is a push or a pull. That's it. Nothing special. If you want a more scientific definition, however, and one that we should probably be more comfortable with, it's an interaction between two objects that results in a transfer of energy. Now, that doesn't need to be a physical interaction. It can be an action that doesn't involve actually physical contact whatsoever. And as you're going to be infuriated to learn later, physical contact is something we should really think about in the first place. So any kind of interaction between an object and another object. It has to be some other external object. Nothing can put a force on itself. There's nothing, I cannot push myself. It can't happen. Okay, that's maybe overstepping it. You could push yourself in very specific circumstances, but it's all just a free flow of momentum. But I'm jumping ahead of myself. So, an interaction between two objects. So right now, it's important to note that the force, while the push or pull is actually happening, is the only time when an acceleration will occur. So after whatever the force is, whatever the interaction ends, is over, all of the change in velocity ceases. There's no more acceleration. Once that interaction is gone, once the push ends, then whatever speed that it is achieved, or slowed down to, or turned into, whatever the case may be, that's what speed it'll go at from then on forward. So if something is at, 5 miles an hour north, and some force causes it to accelerate, and then after it's all said and done, it ends up at 2 miles an hour west, then after that force ends, then there will be no further change. It will stay at 2 miles per hour west for the rest of the time. for the rest of its existence until another force comes along. So with this thought, we need to think about, all right, if it requires forces in order to actually cause something to accelerate, then why is it that we never see things move forever? I mean, for all intents and purposes, if you say something slide across the ground or moving through the air, there's nothing affecting it, right? So then why does everything on Earth eventually slow down? You see things that sit still forever. That's not unheard of. But you never see the keep moving case. Even though I told you a minute ago, that's exactly what you should see. If there's no forces, then there should be no acceleration, and it should go forever. Why don't they? Well, the problem is that forces includes any interaction. And I mean any, no matter how small. And on Earth, there's pretty much always some kind of interaction with some other external object. It might just be the air, but that's still an interaction. That's a small one, but it's there. So the only time that we see inner objects where nothing is interacting on them, and I mean literally nothing, would be in outer space, where there's no air, no anything out there to push or pull them. And even then, it's a little bit more complicated than that, and we'll get to it later. But at any rate, so to summarize this whole video, acceleration does not happen by itself, ever. The normal status quo of anything in the universe is it just wants to keep doing what it's doing. It wants to either stay still forever, or keep moving the same way that it was moving, in the same speed and in the same direction, forever. Any change only happens if there is a force, some push or pull, some interaction that causes it to change. Only in that case will you have objects speed up, slow down, or change direction. And that's it. So after this video, don't forget to do your QSQ. You'll need to answer the questions that were in the video. You should have already done that if you've been following along with the Edpuzzle. You need to write me a little summary of what we just discussed. So I kind of already did that for you in that summary, but put it in your own words, write in complete sentences, you all know. And then ask some question or two. So I don't care what those questions are. They can be something that you didn't understand about what I just said, something that you're wondering about, something that, if you've got a pretty good grasp on this, something that you think might help other people to clarify, or that might be a question that they'd be too embarrassed to ask, which is silly because this is completely anonymous, but still. Or questions for the future of the topic, so something that you think might dovetail off of this, something we might talk about later, or something you would want me to talk about later in regards to this whole forces concept. Okay? So enjoy the rest of your break. See you all on Tuesday.